Hey, Vlad here, devinside.com. Welcome to the next video. In the previous video, we learned about the environment model of computation, which is necessary because Scala, as most languages, admits the assignment operator to the language. And today, we're going to build up on top of it, and we're going to learn about how the environment model of computation basically sort of automatically creates an entire programming style called the message passing style. And in some future video, we're going to see how, based on message passing style, an entire paradigm, the OO, the object-oriented paradigm, is built. As always, we're in the virtual machine, which runs Ubuntu, and we have Sublime on the left and the terminal on the right, which runs SBT, which runs our code. So in this video, we're going to build an entire bank account. So in the previous video, we wrote a partial bank account with only one procedure, make withdraw. And we're going to start there, and we're just going to massage it and massage it and massage it, and we're going to build an entire bank account based on that. And then we're going to see how Scala natively supports the message passing style that we're going to use there. And it's going to start really ugly, and the syntax is going to get like really beautiful by the end. Okay, so let's start with the make withdraw that we it's going to look exactly the same as in the previous video. This is how we're going to start. So it puts a def called make withdraw, and it would get an initial balance, which is also an integer. Okay, and it will produce a function that takes an integer and produces another integer. Okay, so this function is going to be called withdraw, and in the end we're going to return withdraw. And withdraw is going to be a function that takes integer, produces another integer, and its parameter is going to be called amount, right? And it's also going to have a variable called balance. Right, we wrote this thing in the previous video, okay? And the initial value is going to be initial balance. And I'm sorry for my voice, by the way, I'm still a bit sick. Okay, so it's going to check the balance first. So it's going to say, okay, if the balance is greater or equals the amount, well then assign the difference to the current balance, okay? And also return the balance. Otherwise, I think I used to write it here. So otherwise, just signal an error. Sys.error insufficient funds. All right, and I believe we're done. Let's see if it compiles, and it does. All right, so let's create one of them. It's going to be called withdraw 1, and we're going to have a make withdraw with initial value of 100. And we're going to print line. What did we do the last time? All right, so we did withdraw 10 and withdraw a 15. And let's see that. Since we want to grow this to an entire bank account, let's actually rename it to bank account. So instead of make withdraw, we're just going to call it bank account. And this one is going to be called bank account 1. And as a bank account, it should also be capable of not only withdrawing the money but also depositing money. So let's implement that. So it's gonna look very similar. So I'm gonna duplicate this line, okay, and it's gonna be called deposit. Okay, and let's just for fun say that it should also only be possible if we're actually depositing something. So we can deposit 0 or less than 0. So as soon as we have like $1 or whatever currency you prefer, and then we're gonna basically reverse this. So let me copy that, put it over here. So instead of subtracting, we're just gonna add it, and otherwise I'm also going to signal an error. We're going to say it's only possible to deposit positive amounts. And it sort of escapes our window, but it doesn't really matter. And now we sort of have a problem, right? So before, the bank account was just basically a function that takes an int and produces an int. So we would have withdraw and we would just return withdraw. But in this case, we have to decide, like, are we going to return withdraw or are we going to return deposit? We can return both possibly, right? But at least for now, let's see if it compiles. And let's just for fun return the deposit, right? So instead of 90 and 75, it's gonna actually deposit the 10 and the 15. Okay, so the trick is to add yet another function, and its sole purpose is going to be to basically pattern match on a string, or we're actually going to use symbols that are being passed in, and based on that symbol, sometimes we're going to call withdraw and sometimes we're going to call deposit. So a bank account is now going to be not a function that takes an integer and produces an integer. It's going to be instead a function that takes a symbol, and if you don't know what a symbol is, basically you can treat it as a string, right? So it takes a symbol and then it produces this function, right, that takes an integer and returns another integer, right? So let's actually do that. So let's implement this function. It's going to be called dispatch, right? It's actually a vowel, dispatch. So as we already said, its return type is going to be this, right? Symbol int. And in fact, let me actually do this. Let me maximize. Okay, so this is the type of dispatch, right? So it will get the symbol, which will denote the operation that we want to call, right? So it's the operation, and now arrow to the right. And now I'm just going to say, okay, so if the operation equals to withdraw, and this is how symbols are declared, right? So you could also use strings, right? And then you would just have a string here. So if operation is withdraw, well then return withdraw. And otherwise, if the operation is deposit, well then return deposit. Otherwise, signal an error and say, let's do unknown operation, and this is the operation. All right, and now instead of returning deposit, we're actually going to return dispatch, right? So now, if you compile it, it shouldn't compile, right? Because we're still treating it as if it returns withdraw or deposit directly, but it doesn't. In fact, it actually complains because of that. Let's do that. Okay. So now it says, okay, so you require a symbol. Okay, so this is a bank account 1. So what we need to do is before we passing the 10 to deposit or withdraw, we need to say, well, is it actually withdraw or deposit? So first we need to dispatch on the operation, right? So we're gonna specify the operation over here. In this case, it's going to be withdraw. Okay, so we want to withdraw 10, and over here as well, withdraw 10, withdraw 15, and let's after that do a print line, and after that do a print line. Let's do a deposit. And we're going to deposit, I don't know, 125 for example, right? And let's see that. That's the auto completion, right? So it should look like this. Okay, so we have 90 and 75, and then once we add 125 to it, we're back at 200. And let's also add the case where we pass in something that is wrong, and it should explode with saying unknown operation blah. So what you're seeing over here is the so-called message passing style. Actually, let me remove the last one over here because I don't want to see this exception. So anytime you're sort of dispatching on the operation, anytime you're passing a message, see this withdraw together with the 10 is the message, the bank account 1 is the receiver, and the sender is sort of implicitly implied by the flow of control, right? So the answer comes back to the sender sort of automatically, right? So the answer is printed out over here. So this is the message passing style. So what we're going to do now is we're gonna add also another operation, and then we're gonna improve the whole example with native syntax. Okay, so I'm not sure if you remember in one of the videos about subroutines, I believe it was the video about subroutine, which was the video number 6. I told you that you shouldn't mix the functions that produce a value and have a side effect, right? Like this one. So this is what we want to remove over here. So it computes the new balance, but it also assigns the balance to this variable, this one over here, right? And then it returns the balance. So we don't want to have that. So what we want to have is that it just does one or the other. And in this case, we obviously want the mutation, right? So in this case, every time we see this over here, we actually want to return a unit. Okay, so this is going to be unit, and now we don't want to return the balance, right? And the same over here. And now because of that, the code actually becomes more beautiful because now we also don't need those braces. Okay, so I have this and this and that, right? So now if we run our code, it's going to do the same thing, but it's not going to show us the same thing, right? And because of that, we actually want to add yet another function to dispatch on yet another operation, which is going to be called getBalance. So let's have getBalance, and this is going to be a function that doesn't take anything, but it produces an int. Right, so it's going to be something that doesn't take anything, and all it's going to do is it's going to give us back the balance. Now, by the way, this is the first time where we have a function like this. Actually, that's not true. That's not the first time. In the previous video, we had this as well. But if you're returning a unit, you actually specify the type. But if you're taking a unit as a parameter, you actually have to specify the instance. This is like sort of one of those things that you need to know about Scala. So if I type in unit over here, which technically should work, but it doesn't. So it actually doesn't compile like this. See? So we actually want to have empty parentheses here. Okay, so the next thing that we want to do is we actually want to pattern match on that, right? So we want to say, okay, so otherwise, if the operation is get balance, well then return get balance, right? But now we're going to have a problem because withdraw and deposit, they had the type int to unit, right? And this one has a type unit to int, right? So what are we going to do here? Well, unfortunately, we have to write a code that is a bit less type safe. So instead of unit, we're going to say any. Right, which is a type in Scala that is above all other types. So we're going to have an any here, and we're going to have an any here. Okay, and now we're actually going to have a problem. Oh, I'm sorry, I did it wrong. We actually don't want to return a function that takes an int and produces an any. We actually want to return any, right? So this place at the top and this place over here, it returns any now, right? Because sometimes we want to return int to unit, and sometimes we want to return unit to int. Okay, so it should look better now, but it still shouldn't compile, right? So now it says any does not take parameters. So what we need to do now is we need to go here, and we sort of need to turn the type system off, right? We need to cast it into different types. So we need to tell the compiler that this is actually a function that takes what kind of function is that? Takes int, produces a unit. Okay, takes int, produces a unit. Okay, let me actually, you know what, let me do this and that, and let me put this one down over here. Okay, so now if we compile, these two should be fine, but this one is still broken. So we're gonna copy that. I'm gonna do this. Now it at least compiles and works, but it's doing the same thing. But now we can actually, oh, by the way, there's no need to print it out anymore, right? So let's remove this print line here. Remove this print line over here as well, right? So what we want is to print line in between. Okay, so I'm just gonna copy that, put it over here. So now we don't want withdraw, we actually want get balance, and the type of get balance is unit to int, and we're just gonna duplicate it and put it down. So we withdraw, we get balance. We withdraw, we get balance, and in the end we deposit and we get balance. And now it should look exactly as it looked before if I did it right, and I did it right because I actually did not call it. So we need to go here and to go here, and we need to add the parameter, right? So now we see 90, we see 75, and we see 200. Before we continue, let's make this a little bit more beautiful. Let's actually take this one over here, right, and assign it and give it a name, right? So I'm just going to copy that, and I'm just going to say this is the withdraw one, right? And let's just put it over here. So now everywhere where we say this, we can say withdraw one. So now it looks like this: withdraw 1, 10. And the same thing we're going to do was not get balance. Let's do the deposit first. Let's take this and let's call it deposit 1, and let's use it over here, deposit 1. And by the way, if this goes a bit too fast, then maybe you should rewatch my videos about function currying and what was it, function currying and closures, right? It's in the same video. Okay, and the last one is going to be get balance. So I'm gonna have get balance 1 equals this over here. Okay, and now we can actually do that, right? So this looks much better, but it's doing exactly the same thing. So we withdraw 1, get print line, get balance 1, withdraw 1, print line, get balance 1, and so on. Okay, so before we're going to improve that, we're actually gonna have another example where we're dealing with 2 bank accounts. Okay, so we're gonna write a function called actually hold up. Yeah, it should be here. We're gonna write a function called MakeTransfer, and MakeTransfer is gonna take 2 bank accounts. It's gonna take a bank account from, and let's actually have a type alias for a bank account. So our bank account right now is a symbol to any. So let's actually have a type here called bank account, and we can actually call it exactly the same because the types and the values they live in 2 different namespaces in Scala, so we can reuse exactly the same name. So the type of bank account is symbol to any, right? So this is a bank account, and now we can actually everywhere we say symbol to any, we can say, okay, this is a bank account, and deposit is basically a bank account. And so now from is going to be a bank account. Actually, let me comment it out. Let me see that I didn't break anything. Okay, I didn't. Okay, so it's going to take from bank account, and then it's going to take the amount, which is an integer. It's going to take the to bank account, right? And what it will do is, well, it will basically make the transfer. Okay, so what it will do is it will do the from, right? It will get the withdraw, not withdraw 1, just the withdraw, right? It will do the as instance object, right, int to unit, okay, and it's going to pass in the amount. So it's going to withdraw the amount from the first account, and then for the second account too, it's going to deposit. It's going to deposit the same amount. And you remember, if we withdraw something that is less than what we have, then it's just going to throw an exception, and it's actually not going to arrive there. So if I run this code now, and let's actually call MakeTransfer. So let's call MakeTransfer, and we're gonna say, so from is, let's actually create 2 bank accounts first. So let's have this one, which is a bank account equals bank account with initial balance of, I don't know, let's say 50. And let's create that one, which is a bank account with, I don't know, let's say 15. So from this one, the amount is going to be 20, and 2 equals that one. So now if you run it, it's actually going to do everything, but we're not going to see anything. Okay, so what we're going to do is we want to add a few print lines, and for that we're going to have a few helpers. First, let's have a helper for get balance. It's just going to take the account, which is a bank account, and it's going to return as the balance, which is an integer. Okay, so it's going to do account get balance, and custom to a function that doesn't take anything but gives us an integer, and we're going to call it. Okay, and now we're going to have another helper called show both accounts, which is just not going to do anything. It's just gonna print line a string like this, a interpolated string. It's going to do from, and the what we're going to print out is it's going to be get balance, the one that we defined over here, and as a count we're going to pass it from, right? And it's going to do the same thing for 2. So 2. Okay, so now before we're doing the whole transaction, we're just going to print line before, and now we're going to say show both accounts. What did I call it? Count. I want to call it count. Show both accounts. Okay, and now we're going to do the same thing with after. So we did the transfer. Now we're going to do after, and actually let's have a print line over here. Print line like this, and also in the end, let's show the amount. So it's going to be amount, and it's going to be $amount. So now if we run it, it should look. What happened? Where line 61 account, account. There we go. All right. So let's actually not print out these. This one, and actually let's not also do this one. All right. Okay. So we have before, from was 50, to was 15, after from was 30, and to was 35. So I believe it's right because we basically moved 20 from here to here. So now everything works, and all we need to do now is to use the proper syntax actually for message passing style, because message passing style is built into Scala, and in fact it is built into most languages these days. Okay, so the first thing that we're going to do is we're going to capitalize the B, because the types are usually written in the capital letters. So see, unit is a type, array is a type, string is a type, int is a type. All of them are symbol is a type. All of them are written with capital. So we need to write bank account with capital as well. So because of that, we're gonna also return rename the def to the capital B account. So let's do this. Let's see, this one as well, this one as well, this one. What else? Okay, that's it. So let's do a capital B, and now as you can see, the syntax highlighting is also working, and now we actually can save it, and it's still going to do the same. It's still going to work. So now we're going to have another keyword. There is a special keyword to generate environments. So instead of a def, we're going to have a class. In fact, let me actually duplicate this line and comment it out so that you can see how similar it is. So we're going to replace def with a class, okay, and because a class also declares a type, we actually don't need this type anymore. And because we don't need it there, we also don't need it here. And because it's not a function, we don't need the equal sign over here, right? So let me now do this so that you see the similarities. Okay, so instead of the def, we have a class. We don't need the type alias anymore. We don't need to return it because it's not a function anyway. We don't need the equal sign because it's not a function anyway. And because it's not a function, we actually don't need to return anything. Remember, in the very, very bottom, we're returning dispatch. We actually don't need to return dispatch. Okay, so I don't think that it's going to compile now. Yeah, and it doesn't compile now. So it doesn't compile now because we need to use another keyword to instantiate this environment, right? So because it's a class now, it's not a function, so then everywhere we create it, we actually have to use the keyword new. So over here, for example, we're creating a new bank account, so we need to say new. Over here and over here as well. So we only created three different bank accounts. So let's compile, and maybe it's actually going to work. Okay, no, it doesn't work. So the thing is, now that we have a special syntax for creating those environments, we also have a special syntax on dispatching on every binding inside of this environment, right? So everywhere where we say, hold up, over here. So we used to treat bank account as a function, right? That would take a symbol and return us something else, right? So instead of that, we're gonna say. So over here, we're going to say dot dispatch, and we're going to paste it over here. We're going to paste it over here, and where else? Over here, and over here, and over here. And I believe that's it. Here. So we said that dispatch is a bank account, but we're actually just returning a function. So let's go to dispatch. Where is it? Over here? So it actually doesn't return a bank account. It still returns a symbol to any. Okay, so now everything works the same as it worked before. And now comes the trick. There's actually nothing special about dispatch. Look, it's like in the same indentation level, and it's the same, it's just a val, the same as get balance, as the same as deposit, and the same as withdraw. So what makes it so special? Why do we have to go through dispatch? So if you can do dot dispatch, can we also just do dot get balance and dot deposit? And it turns out, yes, we can. So over here, we actually going to say, instead of this whole thing, we're going to say dot withdraw. Dot withdraw. So then we can remove this whole thing with just dot deposit. And this whole thing just was dot get balance. All right. And it still works exactly the same. Actually, we're not doing this thing. Let's actually do this thing over here. Right, so we see 90, 75, and 200, and let's add another print line. Let's add another print line over here. Okay, so we have 90, 75, and 200. And now, look, because they're so short, we actually don't need those helpers, right? So everywhere where we say withdraw 1, we can actually do this, okay? And everywhere where we say deposit, we can actually do that. And everywhere where we do get balance, we can actually do this, bank account get balance. So now we don't need those helpers. And now it works exactly the same way as before. And look, this is so beautiful now. You can clearly see the message passing style. The withdraw and the 10 is the message. The bank account 1 is the receiver. Now let's actually continue with that trend. So over here, instead of doing account dispatch get balance blah blah blah, we can just say over here get balance. And now notice, by the way, we had a helper called get balance, and we passed in the account. And now it's so small that it actually doesn't look necessary. So instead of actually let me duplicate that code. So instead of get balance from, we're gonna say from.get balance, from.get balance, and over here same thing. We're just gonna say to.get balance, and this code is basically just melting, right? We don't need this anymore. We don't need the get balance anymore. Right, it still should work exactly the same as it worked before. And let's do this. So we have withdraw over here, withdraw, and we have dispatch over here, dispatch over here. And now I believe we don't call, what did I do? Oh, not dispatch, sorry, deposit. Right, and now we're actually not calling dispatch anymore, anywhere, nowhere. So we can just remove it, and everything still works the same, right? So it works the same. Let me maximize this actually. So now, because we're moving towards message passing style and we're sort of moving closer to object orientation, we actually don't need those lambdas over here. We can actually use regular defs. So instead of having this, we're gonna have def withdraw, takes in the amount, produces a unit, and that's it, right? So let's have it as a def. This one is called deposit, and this one is called get balance. Let's actually completely rewrite it. Get balance. Looks much better. So the rest of the code, it still should work, right? So we just have the defs, and now because we're using defs, we actually don't need those parentheses over here, right? Because it doesn't produce any side effect. It actually just returns the get balance. Okay, returns the get balance, and now at all the places where we called it, line 37 over here. Whoops. Actually, let's just do this. This. Okay, all of these places, they don't need them, right? So now it looks even more beautiful. So now we're almost done. We just have only one tiny problem. So because we're using this new syntax for this environment, this class syntax, then basically every binding that is at the top level is accessible, right? So now all of a sudden balance is accessible. So now all of a sudden, for example, you could withdraw money, you could withdraw more money than you actually have, right? And this is and we actually don't want that. Let's actually demonstrate that it is accessible. Let's go somewhere here and say, let's set another print line, and in between them, we're gonna print line bank account 1 dot, and we're gonna go straight to balance, right? So we should see balance is 200. Because it's visible, we can actually set it to something different, right? So we can say print bank account dot balance equals 1000, right? And now the balance all of a sudden is 1000. Right, so this is called an invariant, that we have just broken. So it's like sort of rule. This is sort of like one of the points of the environment model of computation, to have your state and the operation that work on that state at the same place, so that they make sure that these are basically the only operations that you can do with this state. So this is solved by prepending yet another keyword to the balance, right? So now if we go over here and we type in private this. So it is private to this environment. Then we can actually not access it. So now if I compile this, it's going to say value balance is not a member of bank account. Let's comment this out. Oh, I commented out the wrong parts. I'm sorry. I wanted to do that over here. Right, there we go. So now it's private to this environment. And by the way, remember I was talking about an invisible pointer to the environment in the previous video. Well, with the class syntax, it doesn't have to be invisible. You can actually use this pointer, which is called this. So every time we're calling balance over here, we're actually calling this dot balance. Let's compile it. Right, so it's over here, here, and here. Every time we're saying this dot balance. And in Scala you actually have another syntax where Scala allows you to rename it, rename this to something else. It's actually not rename, it's actually give it like an extra name. So you can give it some name like self, for example, and just have an arrow to the right. So now the rest of the code is still going to compile, but sometimes if you want, you can use self instead of this. You can't use self over here though. That's not going to work. And the reason why you need this is that sometimes you're going to have like nested environments, and then sometimes you're going to have shadowing of variables, right? So for example, this gets too detailed though. So let's say we had a scope over here, right? And for some weird reason, we would have a val balance here as well, right? Whatever, doesn't really matter. So now Scala can distinguish between this balance and this balance, right? And if you had nested environments like so this balance basically shadows this balance. So if you had nested environments, you might end up having this shadowing, and you might want to distinguish the same way this balance from so this local balance from this balance. But this balance that you're talking about there might be in the parent environment, and therefore you can give them different names so they can distinguish them. But this goes a bit too far. Actually, let me remove that thing. Let me revert that. Let me remove this, and let me remove this over here. Okay, so now we have the private, okay, this one as well. Okay, so private this, and usually languages don't have such a granular way of visibility, it's called. So usually in other languages you can just do private, for example, right? And the difference is that in this, if you have private this, then only this particular instance can access the balance. So if you had something weird, like let's have a function here that is gonna do some shady stuff, right? And it's gonna take another bank account, right? So it's gonna take another bank account like this, okay? Return a unit, and it's just going to do print line other dot balance. So now it's not going to work because it's private this, but if it's not private this, then it will actually work. It will actually compile. But usually people don't do stuff like this. It's actually really weird. So if you don't know this, private this thing, there's no need to obsess over it, right? You can just leave it private, and usually it's enough. Okay, and the default visibility, if you don't specify things as private, is actually public. So for example, in Java, you're actually forced to specify public everywhere. In Scala, it's not even a valid keyword. So if I compile now, it's actually not going to compile, right? So public doesn't actually exist. It is actually common with private variables to call them by starting with an underscore, and it allows us to do something really cool. So everywhere where we say balance, and over here as well, we're going to actually say underscore balance, right? It's just a convention to call private variables like this. So if you're going to have an underscore balance, so now there's no collision between names over here. So now instead of get balance over here, everywhere, we're actually going to say balance, right? So we just renamed this def. That it used to be called get balance, now it's called balance. So the client code looks actually even more beautiful now. So instead of saying bank account 1.get balance, it's just going to say balance, right? Let me see if I did it right. Yeah, I did. Right now I'm actually just going through a few notes that I have here, just so that I don't forget them. So this is the constructor, and as I mentioned in the previous video, usually constructors have a special syntax. Well, in Scala doesn't have a special syntax, and the default visibility for this is actually private this. So it's a private this val. So what I just wrote now is exactly the same as it was before. So from the outside, I don't know, let's see, let's say somewhere here, we can't do bank account 1.initial balance, so it doesn't work. And if I remove this, it's still not gonna work. Okay, And if you actually want to make it accessible, then just do this false syntax, right? Do this full syntax, and just remove the private this, right? So if you just have it as a val, and if for some weird reason you wanna make it mutable, you can also have a var over here. You can't have a def though. So see, this still works with a var, but it doesn't work with a def. So you can't have a def over here. So if you want to have a def, it needs to be here. Also, you can't have a lazy val, I think. Yeah, you can't have a lazy val. Okay. Right. So what else? Okay. So let's actually remove this one, right? Because it doesn't compile now. So the next point is everything is more type safe now. Remember, like in the past, if we would call dispatch with something that doesn't exist, it's just not, it just wouldn't work. And also because of this anything, and every time we would say as instance of, every time that there was potential for a mistake. There was a potential for something that is not caught at compile time. Another thing is that, remember our dispatch, it was the return type of dispatch was symbol to any, and because it would be such a common type for basically any environment that we would create. So for example, if you had a person, right, it would also have some operations on persons, right, and we would have dispatch, and the type of dispatch would end up being the same. It would end up being symbol to any, and this means that for a function like MakeTransfer, we would be able to pass in as a parameter a person, right? It would compile. Of course, it would throw an exception at runtime, but you want things to compile to fail at compile time, right? It's way more type safe, and in fact, in Scala, the type system is more advanced as in most languages. So the Scala community, we love to leverage the type system in our favor. The next thing is that occasionally you don't want to create multiple environments, right? So for example, over here it's obviously necessary that we create different bank accounts. But for example, if we wanted to put MakeTransfer into some place, right? Because the environment model of computation, it gives us those places, right? So instead of using the class keyword, we can actually, let me collapse it. We can use the object keyword, right? So object, and we call it I don't know, operations for multiple bank accounts, right? And it's just gonna have like this, and this thing is inside of it, right? So now Sublime just unfolded it because I moved it. Let me actually collapse it again. So now we're gonna have to use the same syntax over here, right? Operations for multiple bank accounts dot MakeTransfer. Another alternative would be to use an anonymous class. The same as lambdas or anonymous functions, you can use anonymous classes. So you could have a val, operations for multiple bank accounts over here, and over here you would say equals, and just this. And I forgot the new keyword. So we basically need to say that we're going to create a new environment over here. And what's actually happening behind the scenes is that it creates a new version of the so-called any ref type. So this code is exactly the same, but prefer the original syntax that I showed you was the object, right? So with the object, operations for multiple accounts, like this, okay? And also, if you have a class called bank account, right? If you have also an object called bank account, it's called exactly the same, and it happens to be inside of exactly the same compilation unit as the class, and the compilation unit usually means the same file, then this object becomes a companion object, right? So a companion object, it can access things from the private things from classes, for example. Right? So if you had a I don't know, function here, and that would take some bank account, I believe it should be able to do bank account underscore balance. Of course, if it was only private, not private this. Yeah, there we go. It actually worked. It compiled. It warned us about something else. Oh, it's just a pure expression. Doesn't do anything in a statement position. There we go. So now even the warning is gone. Okay. So a companion object can access private members, but not, of course, not private this members, right? Okay. And what else? Of course, the infix notation. Let's remove that. And if the object doesn't have anything, then we can remove those empty curly braces. So the infix notation. So every time in Scala where you say 1 plus 2, it is actually calling the method called plus on the 1 and passing the 2 as the parameter. So by the same token, so let's actually do it over here. So if you're saying 1 plus 2, it's exactly the same as 1 dot, dispatching on the method plus and passing the 2 as a parameter. And the same thing you could apply over here, right? So instead of doing the dot withdraw and passing the parameter like this, you can use the infix notation. Exactly the same code. But now because we're withdrawing it twice, the numbers have changed, and we're not doing anything over here. So okay, let's see. So we have our 90, 75, and 200, same as before. Okay, please avoid the infix notation if you don't really need it. Like a lot of newcomers to Scala, they fall in love with this thing and they use it everywhere. Based on my years and years of experience, lately I tend not to use it at all, unless you have symbolic operators, of course, like plus over here. Over there, then use it. And the last thing, so now that we're moving closer to object orientation, and now that you understand classes, you can actually make use of the Scala API. And because Scala is built on Java, you can actually also use the Java API. API stands for Application Programming Interface, and this is the interface in this case for the standard library that comes with the JVM, with Java, and the library that comes with Scala. So if you go online, like this, if you go to this, and the link is going to be down in the description, then you see all the possible classes over here from Scala, like for example the string class. String. Damn it, my voice is leaving, sorry guys. So for example, we see the string over here, and we scroll down to, so this is the constructor, this is how you can instantiate strings, and these are the methods. And let's take for example method like replace, for example. Replace takes an old char, returns a new char, returns a string resulting from replacing all occurrences of old char in this string with new char, right? And it returns a string. So let's actually try that. Let's actually copy that. Let's go back to our code, and let's go to the very bottom, and let's do a print line over here. And now let's have a print line of some string, right? And let me paste that. This comes straight from the API. Okay, so if we say dot replace, and we give it the old char, which is, I don't know, S, and replace it with the new char, which is the, let's say, capital S, then it should replace some string with this. It will actually create a new string, return it back, and we should see at the very end some string with capital S and S. Okay, and we're also going to have the Scala API, which is under this link. Let's open it here. It's going to be the link is going to be down in the description. So you see over here the version. Actually, let me increase the font over here. You see here the version, and if you replace the current over here with a different version, then you will see the API for the older version. So we go to 2.12.13, for example. All right. It says not found. Why does it say not found? Because why did it say 13? I wanted to, my God, come on. I wanted to say 2.12.3. So 2.12.3 actually exists. So the current one is actually 2.12.4. Let's actually go back to 2.11.11, and you see that it actually also looks a little bit different. They used to use a different CSS for that. Let's go back to current. Okay. So the only thing that I want to show you here is that if you go into some package, like doesn't matter which one, like Scala IO, for example, then you see over here, you see classes and you see object, and you also see another thing called traits, which is something we didn't talk about yet, right? But then basically you can click on it, buffered source, for example, and this is how you create them. New buffered source, you give it an input stream. It has a few things that we never discussed yet, that we haven't discussed yet, but basically you see all the functions here. You can search for them. For example, the search for plus. Let's see if that works. Yeah, so there's a method called plus, a perfect candidate for an infix notation, and it takes, as you can see, a by name parameter with some iterator of char, and it will return also an iterator of char. All right, so we actually arrived by the end of this video, and I know it was kind of a lot, it was kind of fast, and my voice is kind of dying here, but still. right now we haven't discussed like there's still like a ton of nuances in syntax for classes and in semantics for classes, and there's still a few other keywords that we haven't learned about Scala, but by now you should have actually enough information to start writing slightly bigger programs that you were writing before, right? Because classes and the environment model of computation, it gives you, it is an organizational strategy, right? So it gives you a way to structure bigger systems. It's designed exactly for this. Okay. Right, I believe that's it. I hope you liked this video. Subscribe if you want to improve the developer inside you, and see you next time. Cheers.